Ранок, everybody. Let's check, do we have a stream? Yes, we have a stream. Okay. Copy link. Send them to a chat. And let's talk. So, some additional moments. Okay, ранок, everybody. We about a week ago tried to create mesh and create solution for CNC meshing, and there are some problem with this beam, with this aluminum profile, because it have very difficult geometry with a lot of bugs and errors, and we spent about couple hours. Just a moment, how lot time do we spend? We spent about 4 hours to create mesh, but this geometry was very bad, so we stopped previous stream, and today's stream not from the scratch, but from the point where we have end previous stream. So there are CNC house with several type of CNC machine. We work with the smallest one. It's called Mosquito. We take his geometry and try to change geometry, to simplify geometry, to creating more affordable mesh and more correct solution, more accurate result. Without all this correction, mesh look like something like that, and we have a problem with same beam, but also we have problem with a lot of parts which have body and sub part that we don't need, so we need to do some changes, because this part take a lot of mesh, and this mesh doesn't give our result more accuracy. It bring to our task, to our solution, only size, only time that we need to spend to get our results. So we need to do some changes. I want to ask and to apologize about my level of English, because English is not native language for me. That's the first things that I need to say. Second, it's very hard to work for a long and speak for a long time. So please be patient if my pronunciation and some words are not fully correct. You can write the comment below with some correction, so it will be a good possibility to me to do my best to increase my speech skills and so on. That's the first things that I need to say. Second, you see, when people create stream with game, for example, it's very dynamic, it's very colorful, it's very attractive. But when we show the real process of something in CAD, CIM, CAE, it's not so dynamic, it's not so attractive. It's a lot of same operation and so on. So maybe it's not so good, but we demonstrate full process with all mistakes, with all errors which obtain from my side, and which can be found in software. So we don't cut with anything, we show full process, and you can see how the real process look like in real life. With real time of spending, for example, when we create mesh, it takes some time. In CAD, when we do mechanical design, for example, a lot of people think that if we spend for some operation, for example, 1 minute, it's a very long time and a very slow process. In mechanical design, yes, it's so. But when we talk about CIE software, when we talk about computational mechanics, when we talk about FEA, FEM, so finite element analysis, finite element modeling, and so on, we need to understand that we have another scale of time, because if something are done in a couple of minutes, it's very good speed. And when we work with big model, this is not very big, but it's not only one part. So when we talk with bigger geometry, with bigger task, we need to spend much more time, and these streams show, as I said previously, real speed, real time that you need to spend. Additionally, you need to understand that it's not the full time, because we show process and we show some simplified process. We don't show full number of things that we must to do to create a very, very good solution, because for this geometry it will take not couple hours from the zero to the end, from the beginning to the end, but it will take about couple days, because you need to check a lot of things before you will do report. So here we show full process from the scratch, from the beginning to the moment when you obtain solution, but not the full process of creating full report with good accuracy and so on. So this is how our geometry look like after simplification. For example, this bearing convert from the sub-assembly to only one part, and it's very simple process to create mesh here. It's not very good mesh, but it's a small number of elements. We will create better mesh here, but we have a big problem. with this geometry. And we have two kinds of problem. First of all, during simplification and correction with this profile, we have facet geometry, we try to fix them, and during fixing process, we convert our solid geometry to surface geometry. So it's not a solid for now, it's surface. And we can't create a solid mesh, we can create only shell mesh for this geometry. So we need to fix them. Okay, if we open our geometry, we can see that this part, this aluminum profile, extruded profile, are transparent, and discovery show by default with transparency color surface geometry. So we check something, select something, sorry, and we open our component, and we see that it's transparent. In discovery, in space claims, there are some possibility to improve your geometry, even if it have some errors and mistakes. You have tab which called prepare and tab which called repair. So this one helped us to convert some object like this to a beam object, for example. Beam in terms of finite element analysis and finite element method. We can do some enclosure for our geometry. We can check interference, we can delete small rounds and fillets, short edges, and so on. So we can do our geometry better. These tools use this number of tools, but do it more automatically. For example, if we take short edges tool, we can see that discovery show to us place where we have short edges, and if we click on these red dots, they try to do automatic fixing of this geometry. But it's simplification geometry, and this simplification can do some problem with geometry as we do earlier. So sometimes we need to repair, to fix errors. We already use merge faces here to glue some small faces into one, but we have some problem. For example, we have some gaps. If we use this tool, we see here we have a gap. So if we click here, he tried to fix this error. We can also see that we have analogical problem from the other side, and our profile are not transparent, so it's solid. We can see here, yep, it's solid. please see that when it was before this fixing, we have icons like here, and after fixing, we have icon like here. So we fix this geometry, we can save, and we can update our geometry. Ouch. Sometimes it happens. Okay. And it's happened in my fault because I open this tab with only this geometry, so it loses all other geometry. Yep, it's my fault. Open geometry. It will need some time. Not very long, about 1.5 minutes, something like that. And now we will try to create a mesh for this geometry with not very good approach, but this approach sometimes help to us to save our time and sorry, nerves. Okay, save our time and our nerves. What should we do? We hide all other geometry. Hide all other bodies. And we will use creating of tetrahedral mesh, but with additional manipulations. Previously we tried to create sweep method, but it's very difficult for this geometry because we have a lot of surface, a lot of edges and so on. It's very difficult to create a good mesh for this phase and to reproduce, to sweep them to all that beam. So we try to create a tetrahedral mesh, but we will not change this option. If we will change this option on mesh, sorry, not this option, quality, check mesh, quality, and here, check mesh quality. So if we change this option from yes error to no, we will get mesh, and in most cases this mesh will be very poor of quality. So it's the reason why we don't use this mesh, because if we want to have accurate result, that's a bad idea. Okay, but we can create mesh even with this option when we check the quality of our mesh, and we stop if our mesh are not proper, but with some simplification of process. We will check this geometry, we use method, and in most cases, all our geometry meshed with automatic method. He tried first of all to do sweep method, then he tried to create multi-zone. It's second methods when what they try, and if it don't help, they try to do tetrahedron or hex dominant mesh. But this mesh tetrahedron can be done with two different options. Here, algorithm that we need to change. First of all, in most cases, it uses patch conforming method, and we change it to patch independent. 0.5 millimeters we will the feature, and mesh size will also be 0.5, so something like that. Now we try to create mesh for this geometry. Also we add on sizing and say something about 20 millimeters. 20 millimeters. Yeah. Okay. Let's try, and it will take some time, so I will explain what we try to do. Sorry. Create mesh only for this body. Oops. Misclick. Generate mesh on selected body. It will take less time. So, what do we have and how patch independent and patch conforming methods differ? Why it's also green? Okay. All these faces we can call patch of surface. Every example you can see here. And when we create a patch conforming method, our tetrahedrons created directly on our geometry with corresponding to all patches, to all faces, to all curves, to all edges, to all points, and so on. So, for example, if we have geometry which look something like that, and here we have a points, and the blue part is the edges or curves. What we will get with patch conforming method? He will create nodes, yellow, here on all our points. If we try to create elements with this side, with this size, for example, but we have in this scale those geometry, it will not create nodes like this. It will create nodes and elements like this. It will create nodes on every point. It will create nodes on our curve additionally, because in our property we say that we need minimum 2 elements during our age. So after he creates those nodes, the mesh will be like this. And all these points are nodes, so we have not one element, but 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Not one, but 8. Because he can't create one element with nodes only here and here, in reasons that we have a lot of nodes. If these nodes will be with very small distance, he will merge and we will have bigger elements. But in most cases we doesn't have points very close to each other and we can't merge our nodes, and we will get something like that, something like this geometry of elements. So what should we do, and how work a patch independent method? We create certain geometry with a lot of curves, with a lot of edges, and with points here. When we say that we create patch independent mesh, it ignores all points, it ignores all edges, and not try to create as many nodes as he can. He tried to create one node and then use this geometry look like it's only one edge, and create second node on a certain distance, and after that he create a mesh. As you see, it needs spend much more processor time for ignoring our real geometry, for creating our mesh in according to our geometry, but with ignoring some small features and so on. So it will spend much more time than if we create a patch conforming mesh. But this mesh can be less size, with smaller, less size in number, not in size of elements, in number of elements. And this mesh will be better quality than patch conforming. But as you see, it will spend a lot of time. On the previous stream, during couple of minutes, about 5 minutes, we already create a mesh here or obtain results that we will not get our mesh. So for creating mesh with patch independent method, for this part we need to spend about half of hours or even more. We will not spend this time during our stream because it's not very interesting. So we will spend this time to create mesh even for this geometry and with more adequate method. But we will do it by our hand. So we stop this mesh. We spend about 15 minutes to create this mesh. So as you see, it will be a very long process. To all people who join to our stream, Ranok everybody. Ranok in Ukrainian it's morning, so we can translate it something like morning everybody. Everybody, it's everybody. Boris Johnson, Prime Minister from Great Britain, came to Ukraine and say Добрый день, everybody. It's something like hello, everybody, or good day, everybody. I start my Ukrainian and Russian language with catchphrase morning in Ukrainian and Russian. So in English version, I think that we create a variant of morning, everybody. Something like that. So, additionally, I say that I change some preferences in sound. I try to look on a previous stream and see that sound was terrifying. Sometimes it absent. It's in reasons that noise reduction was on, and sometimes, unfortunately, near my house present some loud sounds like strikes and bombs, and like an air alert, sorry. It's not the word that I use very often, so I need to translate it. So sometimes we can hear air alerts or very big booms. So noise reduction clip the sound and clip with my voice, unfortunately. I change preferences on noise reduction, so I hope the sound are better, and if this sound on this stream are better, please write the comment. Okay, what should we do with this geometry to create a better mesh? First of all, we need to simplify it, but we already simplified. But we simplified it as one part, and we need to simplify this geometry. We can simplify it by splitting this geometry to several parts, and full geometry will be not simplified, but every part will be more simple. Let's try to do it. We'll open Discovery. We open our geometry component, open, and we split it. First of all, we have this midplane, and we use it to split. Additionally, it will give to us information where do we have a problem. So we split body and split it with this geometry. Okay. Also, we will create some additional planes to create some simplifications. That's one. Second will be here. Also we will create a plane here. If place will be not in a place what we want, we can move it. Additionally, we will create something like this one in this place. Someone think maybe that this process are not legal, but it look like direct creating of elements, so it's not illegal operation. But we need to understand that when we split in geometry, we can not only solve problem, we can obtain some problem. So we must understand what we do and check result. Okay, it's enough. For example, for now, so we will split body. We will split this body with this surface, with this plane. Sorry, it's not surface, it's plane. With this plane and with this plane. And we will do the same with this geometry. So split by this plane, this plane, this, and this. Ранок, Leonid. Yep, you are in time. Does the sounds better in stream? Because I can't hear myself. So please answer, does it better than in previous streams? So we split our geometry, something like that. It's not very good, for example, here situation. It will be much better if we will have something like this geometry splitting. Additionally, we don't need splitting, for example, here. So sometimes it's better to change some option and to split again. But for now it's not very bad. But we will fix here and will not fix here. And we will see the result. So fixing splitting here will be very simple. We will say combine, check this one, with control check, select this one, and we obtain result that we want. That's good. That's our one geometry. Here it's split to two body. Here is one body. For creating mesh here, we can not mesh, splitting. We can select something like that. We can select edge and faces and say plane, and it creates a plane which are normal to this face. It's perpendicular, so we will get better mesh here. Additionally, we can create mesh, for example, we can create a plane with two edges. As you see, I try to create something in a different ways, so you will see different ways of solving some problem, and it will be more dynamic process. I understand that this process are not dynamic and not attractive, but it's real work, so something like that. We can combine to this body and then split, and we can split this body and then combine. It's not matter. So we will split our body with this plane first of all, and second, as I say previously, we will combine these two geometry object, and now it's hard enough to talk for a long time on a non-native language. So we will split this geometry with this plane, and it's maybe not normal, not perpendicular to this face, but it looks much better than previous version. So we will delete all planes that we already don't need. We will combine to these parts. You need to understand that when you create splitting in Discovery, you will sometimes get in some place very small object and very small features, and it will affect your mesh, so you need to check the result of your splitting. So we have something like that. As you see, it's much more simple. So every part has less number of faces, have more simple geometry, and mesh for all these parts will be created on parallel process, so we can use multi-core, so we will obtain better mesh for this geometry. But after updating our geometry, we will just a moment, we need to open tab with full object. because we will have error after updating. Will it work as a spring? I don't understand question, sorry. It's a beam of CNC machine. It's this portal beam. So it's not a spring, it's a beam. If I understand correctly. Okay, let's try to update. We will get message like this. One or more parts were found to be unmodified, so smart updated. It's very cool. It means that we don't update all geometry objects. We update only that geometry object that changed. And that's cool because it spends less time and so on. So, as you see, our parts, our beam, will look like here, like this one, because the number of our beam aluminum profile stay with this part of geometry, and all other parts of geometry will have other numbers. So, no, we have some problem. As I see, we have problem in reasons that multi-body parts are not came to Ansys Workbench, Ansys Mechanical. It's very strange because I do this for very long time, but do this with space claim, and I haven't problem during such updates. Sorry. So I understand why we doesn't have here some beams and aluminum profile and so on. Let's try to fix them, because this beam, I don't like this beam. I want to have full beam. Yes, it will be created, mesh will be created with better ways. It will be very accurate and so on, but it's not a very good solution. So let's do some improvements and fixing. Okay, maybe I know what we need to do. We need to open this one and we need to check all body and right mouse. Say right mouse. Why do you don't want to do anything? Select all body. Move each to new component. We don't want to do that. Why? Let's select couple. Appearance. I don't want appearance. I want to move each to new component. Okay, you don't want to do that. Let's something looks strange. Okay. Let's do that again, but with another way. We will close all tabs that we opened in previous session. So we close all sub-assemblies, and now it's an x-axis. Component open. Okay, that's better. Please something looks strange. I think I split here. No, I don't split here, but we can split here, but we don't. Okay, locate on tree. Okay, open on component time. Tab, move to new component, are absent. In reason that it's a mirror. And this one, all this object are mirror. Okay, let's delete this plane. Something strange with patterns and mirrors in Discovery. Delete. Okay, let's do the dumbest way I ever do. We will copy all this. We will create new component and we will paste. No, it's not working. Yeah, it's work. It's very strange. I don't understand why. No. Not delete object, delete a mirror. We select this one, we select this. What the hell? I'm sorry. No, I don't want here, I want here. Something look very strange. Nope. I really don't understand what I have going here. Why it's working so dumb way. After we split in this geometry, we will must to delete all mirror references and so on. Activate. Body 4, okay. Can we create something like a folder or something? I don't know. Inverse visibility, just for example. Okay, let's delete all those. Why you show this? Component, move to new component. No, we can't. We already doesn't have any mirror plane, but we can do. Why? Why are you so dumb? Or maybe why I so dumb? Okay. New component. New component. And a new component. We will try to check some things. Okay, we will Control X this body and place it here. why you place here. Okay, activate this one. It's not important, but it's very interesting. We cut this geometry object and place it here. And we cut this object and place here. So we have 4 different edges. As I see, in discovery process of working with subassemblies are much dumber than in space claim. Unfortunately, I doesn't have license for space claim, and it works with some errors. So, okay, we do some changes and we will try to check what would we get after that updating. Comment. I thought it's separate structure from plastic or similar. No, it's not separate structure. It's one of the main element of construction, and it's done from aluminium, and full CNC machine done from aluminium, so something like that. And where the heck are our geometry? Aluminium profile. And now it doesn't have any sort of body. Not what's going on? Ansys, what would you do? Just a moment, maybe I don't know how we activate component for modeling physics. Okay, let's include in simulation. Oh, I understand. Locate in tree, yeah. And why did you change the status of this body when I splitting and says that we don't want to use it in simulation? Very dumb idea. It's very dumb idea, and now I understand why it's absent a lot of parts. So let's try to do something like that. We delete all parts that we don't need, so we not need select something here and say exclude from simulation. And now let's try to update geometry, and we must obtain all object. Yes or not? Yes. And now we have this beam, we have this rail, we have those objects. Wow. I'm not Golem, but who read The Lord of the Rings or Hobbit in English, please say my darling or my pretty. I think my pretty, but something like that. Okay, now we have all object. That's very good, and we can create mesh. We will hide some geometry object. It has some gaps, but it's not very important for now. So something like that, and let's selection, and we will select all those bodies for better operating with them. Create selection X BM. Okay. Now we here our name is selection. Now we can say show all bodies first of all, and then only hide bodies in group. Okay, invert visibility, something like that. So we have all beams, and let's change our sweep method from geometric method to XBeam selection, named selection. Now it's unsuppressed, and we will try to create suppress sweep method, not automatic but sweep. Source, let's try automatic source, and let's create mesh. So we have F4 viewers. That's cool. And maybe someone have some question. As you see, we create mesh for one geometry object. Yep, it's a lot of parts, it's a lot of volumes, it's a lot of bodies. But it's one geometric object in reason that it's one beam. And it uses all 6 cores on my processor, and that's very good. So I wait a question. If someone has them. There are no questions. Okay. So okay, as you see, we have obtained mesh almost for all parts. These parts are not have mesh in reasons that we failed this mesh. So we need to do something with this geometry, and when we will fix it, we'll have something analogical to all other parts. So it's triangle in base and prism in full 3D view, but it's not a problem for now. The main problem is that we doesn't have mesh here, and if we will try to look, we see that we have something like here, this in this place, and we have something analogical in this place and in this place. And here we obtain a mesh, and in mirrored part we doesn't obtain a mesh. Sometimes it works something like that. Okay, what do we need to do and what do we need to understand? We need to understand that we have some places with bad geometry that we need to fix. Virtual topology, and if we take a look to virtual topology, we will see that we have, for example, merge geometry here, and we see it on a mesh, but we have problem here. And why we have problem here? And we have problem here in reason that we have one surface virtual topology, but we have multiple edges, and as you see, it creates multiple edges here. So we need to try to do something like that here, and let's try to do analogical situation here. So as you see, on the top we have one merged surface virtual topology. Here we have a lot of face, so it can create a mesh here in that reason. So we will create virtual topology by our hand. We select all this object and create merge cells. Additionally, we need to check all these edges and match them additionally. That's look like, as I say, patch independent method. But when we create patch independent mesh, we do something like that for wall geometry, for all geometry object of this body. When we do something like that, we ignore geometry only in some places. And this glued geometry, these glued faces, came from discovery. And we create additional virtual topology not in discovery but in Ansys. Sometimes we need to do that even if we do something like that in discovery, because they will have because during translation we can have some problems. Additionally, we need to glue geometry objects here. In reasons that in other way we will have difference in difference in phase, and it will not create a certain mesh. So for now we select those objects, merge them, and we will obtain better mesh. Tens. Oops. Okay. And then we will do it in another way. Something like that. Okay, let's try to create mesh for those bodies. Sorry, box select. Ouch. Create mesh for this body. Some waiting. And as you can see, we obtain mesh here much better than we have previously. But we have a problem with other body. Okay. It's not a problem. So why do we have problem here? Let's try to take a look. Virtual topology from one side, and we don't create a virtual topology from other side. Okay. Let's do something like that. Additionally, let's create virtual topology here. And check it. Okay. Mesh, and we have two problem. This one was good mesh, but we do some changes with the geometry, so it is purple. It's obsolete mesh. We need to recreate mesh here, and yellow or yellow-brown, it's failed mesh, so we need to also recreate this mesh, but in other reasons. So we select to this object, we say generate mesh, and yeah, we create mesh. Okay. And why these objects are not have mesh? Generate mesh on selected bodies. Nope. Why? Why this body will not have mesh? Okay, let's hide the other bodies. And let's take a look to them. It's normal body. Sweep method. What is this? Now maybe it's simple. Graphical bug. But why? But how? But why? Let's check in another way. Select, create selection, geometry with this size, for example. Here we have selection. Okay, let's check. Let's convert head, and we will convert to not body but faces. Generate. Wow. Sorry. Sometimes 6 faces. Okay. Convert to edges. 12 edges. 4. 12 edges. Yep, it's not a problem. So why do you don't create a mesh for this part? Show all body. Hide bodies in group. Invert. Why did you don't do here? let's try to do something in another way. So sweep method, not automatic, but and we can't create not automatic method. We can't create manual method. Yep. Let's create quad first of all, and second, I create this part. I want to say that this part will not have problem, but it have problem. So it's very interesting and very very strange. But I have one idea. Generate mesh on selected bodies. We say that we need to have 250 division through the lens, and maybe it tried to create sweep not in this direction as for all others body, but for this direction or for this direction, and he obtained very bad mesh. So when we say that we don't need a triangle mesh, we need a quad mesh. We have some problems with some object, and we can see why. For example, here we have mesh, but these mesh are not very good. So we need to do some changes. Let's try to do it. Face meshing and face sizing. Okay, let's check all these meshes. Select all these meshes. All these faces, sorry. And face mesh. Okay, and unsuppress. Generate mesh on selected body. And we have a problem. It's interesting. Okay. Preview, surface mesh, unselected bodies. Yeah, as I say. Yeah, it tried to create mesh during this direction, with this direction. Okay, let's do some changes. We delete this sweep method and we do something like that. Mesh methods single, sorry, something like that, automatic sweep, not automatic manual source, and this surface, for example. It's very interesting. Can I do with several? I don't know, will it work, but let's try. Sorry. No. With manual source we have only one. Okay. Okay, method sweep, method sweep, method. Not multi-zone, but sweep. Method sweep. It's a very strange idea, but something like that. Method sweep. Okay, so method sweep, method sweep, method sweep. Very intellectual work. Sweep, method sweep, method sweep, method sweep, method sweep. Okay. What should we do? We select all geometry object. Okay. We change source and target to manual source. We input 250 divisions. Okay. And now we will select the right faces, sorry, for all object. Maybe it can be done with other way, but unfortunately I don't know about that. So we create it in this way. Maybe I'm idiot. Maybe I'm dumb and there are more simple solution. I don't know, really. I say that I'm expert in Ansys, but I don't know. but there are always some things that we don't know. So generate mesh, something like that. Sorry. Not for full object, but only for that. Xbeam. Mesh. Generate mesh on selected bodies. Now we have mesh for this part, and we doesn't have mesh for all other part. Face mesh and mapped mesh, no. Yep. Let's suppress this one. Maybe it will help to us. Generate mesh on selected bodies. Yeah. Yeah. Okay. And we have very exciting mesh. And you can see, for example, here we have mesh which look like this one. You can see. And here we have mesh which look like this one. We have triangle here, we have triangle here, and here where we have create normal plane and do some changes, we get much better mesh. But in some places, unfortunately, we have problems. But this problem we can solve by changing face sizing, by changing some preferences in meshing and so on. So we create mesh here, and that's very cool. Show all bodies and create generate mesh for all others. Yeah, we have. So we have mesh here and we have mesh here. Let's take a look to this body, hide all other body, and we see that it's the same body. It's the same body. Let's see how many elements does we have. Go to corresponding bodies in tree. It's our body. And we have 100 nodes and 100,000 of nodes and 20,000 of elements. And with those geometry, we have 42,000 of nodes and 22,000 of elements. It looks very strange. Oh, I see. We have, as you see, element size like this one, and here we have element size twice bigger. But if we will take a look into the shape of elements, we will see that here we have better shape, but not always, not for all elements. So we need to create a good mesh for both of these faces, and we will have good elements for these beams. Let's try to do it. Method, this one, apply, it's not automatic, it's sweep. This one, it's not automatic, it's sweep. Both of these sweeps are not automatic but manual. For this object, we will use this face, and for this object we will use this face. Number of division, let's choose something about 100, and generate mesh. Not the same body. Why? This body are not the same. Look very similar. So it's this body. Let's open. And what problem we have here? For the first side, there are no problem. Maybe bad faces? No. Maybe short edges? 1 millimeters? No. Maybe gaps, missing faces? No, there are no problem. So why do we have problem here? Especially those both object was mirrored. Okay, let's try to not sweep this one. It doesn't see a place of problem. It doesn't see a reason of this problem. It's not cool. Okay, let's change, for example, to multi-zone. So it's a long process to find the bug and so on. Okay, it doesn't have a result. Multi-zone are not right. For my thoughts, it must be sweep. I don't see any reason of sweep can fault, but Ansys see some reason. Let's try to create something like that. I don't want to split this object into subpart because it doesn't have any sense. The reason that this part are normally meshed. Okay, let's try to do something other. Let's do sizing for this and this object, and it will be 2 millimeters. Okay. Generate mesh on selected bodies. Let's take a look. Nope. We have much better mesh here, but it has some problem, but we doesn't have good mesh here, and Okay, just a moment. Here we have adequate mesh, and here it don't want to mesh. I don't understand why, but let's try to change 100 to 100 and half. Sometimes it can help in reasons that we will have better ratio. Nope. Who is dumb? Who is idiot? Is it myself or not? Okay, let's see what would... Just a moment. Nope. We change one of the properties of this method. I say create a triangle mesh, and it can't. What the hell is going on? It doesn't have any bad faces, it doesn't have any short edges. So I don't understand, really don't understand. Just in case. Okay, sweep method. First face. Let's use this face as first. And this first as second. I know that's a dumb solution, but Nope. Okay. Let's do some changes. Mesh copy. Source anchor. I want to copy mesh from this object. No? Okay, from this object to this object. Okay, I think we will not spend time for this object because these two objects are identical, and we can delete this one. We will place this one here, and we'll create a mesh in that way. If something works not as we want, we will change it. So return to our geometry. This, let's take a look here. Show all object. Yes, we doesn't have mesh for this part, so we open geometry, we hide this component, hide this object. Now we select this component, Ctrl C, Ctrl E, and move. Also, we change the marker to this place and move up to this body. Okay, now we have certain copy. Let's open our y-axis and let's find let's exclude those part from the simulation and use copy of good geometry for our case. Stop meshing. And I say it's about 2 minutes ago. No. Stop. What's going on? I kill this process in reasons that he is freezing. So show bodies, okay. Mesh. Ouch. Ouch. Okay. Generate mesh. It's not saved. Yep. Sometime it's problem. Okay, we see that we can create mesh for this beam. So I will not repeat creating mesh for this beam. It will spend some time, but we already see that we can do it. Now we need to understand that we can create mesh for those two beams. And after that, we will take a look how to create better mesh for those element, and so on. And that's why real work sometimes spend much more time, because it frees, it fell, but you need to repeat it. During the stream, I show that we can do it. We can do something like that. So we can spend some time to other part of this problem, and don't spend time to repeating that we already do, but it fell. Additionally, I must say that I have done about 10 presentation video with presentation on Ukrainian language about Ansys, about interface of Ansys Workbench, and so on, about what is Ansys company. So I can create this video in English, but I need to do some translation and so on. So in details of video you can find information about Ukrainian speaking language, Ukrainian speaking channel, and you can find a description about Patreon, so you can do some not not necessary money infusion, optional money infusion to Patreon, and more money, more speed in creating video, something like that. And it will be not only a stream with long history, it will be a video with presentation, so it will be more short, more detailed, and more dynamic, something like that. Okay, for this geometry we need to do something like for this object. So we try first of all to create a sweep object with about 400 elements. Why 400? 100 elements during its extrusion direction. Nope, it doesn't want. Okay. Manual source and targets. This is manual source. Let's create size for this face. It will be, for example, 2 millimeters. Generate mesh for selected body. I would be very appreciate if someone will be Patreon for this channel. For all Ukrainian, it's very important for now. So, nope. Mesh failed to initial. Oh. Oh, it's problem with mesh. Just a moment. Let's check. Hide the laser body. Okay. Method multi-zone. Generate mesh on selected bodies. Yes, it create. And for object like this, as you see, we can create a much better mesh with multi-zone method. It's not a sweep, it's a multi-zone method. It's like we do some splitting, but these splits will done automatically. As you see, for example, here, it's like this part was splitting by this surface and was splitting by this surface. So sometimes multi-zone is very good variants to create mesh with very fast variants. What can we do? We can select this edges and create edge sizing, for example, not element size but number of division, 3 number of division, and we select those two edges, create number of divisions 2, and now we recreate the mesh. Yep, it's look much better. Also, we can create a better mesh for this surface. For example, as you see, we have some bad elements. We can check this face and say that we must have mapped mesh. Let's generate. Bingo! We have much better mesh. Yes, we need to add some sizing to this surface, but as you see, we can create good mesh with multi-zone and sizing for this part. Okay, that's good. So show all bodies, and let's repeat to this body. For this body, for example, let's create a mesh with sweeping. But first of all, we will click on the right mouse button and try to show parts which can be meshed with sweep method. Right mouse button, show sweepable body. And as you see, we can take a look for a lot of parts. For example, This one is not sweepable. I don't understand why, but we will check them. As you see, we create a lot of parts that can be meshed with sweep. Some of them must have additional preferences, so we will do it by our hand. Let's hide all other bodies and see why these objects are not sweepable. Show sweepable body? No. This geometry are not sweepable. Why? It has something. That prevents sweep meshing. And I don't understand what. Okay. Maybe we have some small edges somewhere. Let's try to take a look. Display, direction, show vertices, closed vertices. And nope, there are no problem here. And there are no problem here. I don't see a problem. I don't see any problem. Okay, we need to split them and then we will mesh. Maybe it will be a good solution. And for today we will create a mesh which will be something like that. This mesh, but not automatic, and it will be hex dominant. Generate mesh. Nope. Okay. Let's do it in another way. All these faces, excluding these two, and we say that we must create face meshing and it will be mapped mesh. Something like that. Okay. Generate mesh on selected body. Let's see what happened. What it happened. Much better, but okay. Let's add some information. Let's add to all these edges sizing, and we will say number of division 100, for example. Okay. Ouch. Generate mesh on selected body. Not display direction. Not display. Much better, but am I idiot? Ouch. Aha, I see. We have here an edge, and here we doesn't have an edge, as I see. Yep, we doesn't have edges in internal corner. I don't know why, but in all internal corner we will not have edges, and as a result we see something like that. Yeah, it's tricky to create proper mesh here. Okay, so we need to open this component and we need to fix them. So here we have an edge, as you see, but we doesn't have edge and what should we do? Yep, it's plain. Why it spoil and corrupt our geometry? I don't understand. I don't understand why it corrupt our geometry. Here we have, and here we doesn't have. Okay. Y direction. that direction. Something like that. Nope. And here we have other problem. Oh, I see. But why? Okay. It can be fixed. Delete. Yep. Yeah. And I think I know why. It corrupt our geometry. Maybe something like that we have on previous beam that was identical but not meshed as sweep. Delete. Okay, let's delete. Let's create sweep meshing. We delete not all. This one delete. Okay. Show sweepable body. Yeah, already. So we delete to this object. We change sweep. We say 100 of sweeps and generate mesh on selected bodies. So why do we have a virtual topology on this geometry in situation when we doesn't create a virtual topology on this geometry? That's very interesting situation, but sometimes it can be. You see, yep, we have good mesh, so it's better. So during previous session, during previous stream, we create virtual topology on some object of C-beam. Show all bodies. We create a virtual topology for this beam. Just a moment, I will hide body. Selection. C-beam, it's like C. It look like C, but in terms of CNC meshing, it's beam of X, portal of X axis. So this object have some places with errors, which we must fix. We fixed this we fixed this geometry by splitting and simplification by splitting, first of all, and second, we do virtual topology in those places where we have a lot of points, a lot of vertices, and a lot of elements. But in previous session we do automatic virtual topology creation, and in some place we create by our hand, in some place we create by automatic. And you see, when you create some object in Ansys Mechanical or in any other CAD or in any other CAE system, you will use internal number of this object. So when you select, for example, this surface or this face, you can selection information, okay, you can see some additional information. This is information about surface area, centroid, and so on, but most important, this information. Reference ID of part ID, internal reference of all faces, and reference ID of this face without information of part ID, and so on. So it applied not to surface that we select, it applied to surface with this number. And when we change some geometry object, when we change something here in Discovery, or in SolidWorks, or in other CAD system, and we re-import our geometry to our Ansys Mechanical, they try to find object with this number. If it doesn't find, it delete from the list, from the selection list. If our selected selection list will be empty, it will show error to user. But if it find object with those number, it will apply virtual topology, contact, fixation, loads, mesh property, and so on to this object with this number. And in reason that we do big changes in our model, our numeration of faces are changed, and it apply to object with the same number. And for this geometry, this same number, for example, was here for these faces. You can see this one is also, as you see, height body. For example, this one is also virtual topology object. We don't need them because it's already one surface, but it creates. Oh no, it's not one surface, it's not one face. So okay, it finds two faces and create virtual topology, something like that. Okay, context we will delete for this moment, it's not very important. We recreate a mesh. Very powerful things from Ansys. It mesh created only for body what have some changes, which have some changes. If body change geometry, or if we change preferences of meshing for this body, it tried to create new mesh. Also, it tried to create mesh for those bodies that doesn't have meshes. And it's very cool because it don't take other body which already have good mesh. Lot of CIE software, especially which oriented on CAD user and especially which are present inside of CAD, for example SolidWorks simulation, Nastran in CAD doesn't use information about some objects, some parts, some volumes, some bodies have mesh already. It tried to recreate a mesh from the scratch for all bodies, and that's very sad. Okay, for this body we check situation, we create good mesh, so it's very cool. And we need to understand how we can create good mesh, for example, for this object. Hide all other body. And we see something like that. Let's try to create multi-body. I think it will not work, because here we have much difficult geometry, much more complex geometry than when we in previous version use multi-zone, but let's try, maybe it will create. For this geometry we can go with several ways. First of all, we can split this geometry in several places, and all parts will be much more simple, and we will receive possibility to create good mesh. Okay, it don't want to work with multi-zone. Yep, as I said previously. So we need to create better mesh. Let's try to do it. Just a moment, I take a look to this object. No, we need or create tetrahedral mesh, for example with 10 millimeters of size element. So we change multi-zone to hex dominant or tetrahedral. We create element size for this object, for example 10 millimeters, and generate mesh. Or we need to split this geometry if our resulted geometry will be very bad and we can't create good geometry. But for me it's not bad mesh, it's much better than was previously. Yep, we have some places, for example here, with not very good, with not ideal, with not perfect mesh. Also we have some problem in reasons that it's not mapped mesh, and here we have two elements during the thickness, and here we have only one element. It's a bad idea. It's a very bad idea. It's not error, but it's not a good idea. Even if we use elements with mid-side nodes, it's better way to have here two elements. But we will not have here two elements in reason that mapped face mesh we can't create here. We will try, but for my thoughts we will not get. Generate mesh. Also, even if we have on this face good mesh with two elements on the side, there can be situation when in some places, for example here, we will have one element during the head. Let's check this one. No, it's very good because in most cases we have two elements during thickness, and that's good. It sometimes look like that way. It's not square. It sometimes look something like that. It's twist. But it's not a problem. It's good mesh. So, okay, we get result. I think that Ansys will have problem with creating mapped mesh on this face, but it create mapped mesh, and that's cool. So for this part we create mesh, and that's good mesh. No. Okay, show all bodies, and we need to create good mesh for this part. Select this part, method, hex dominant, sizing 10 millimeters. Generate mesh for this object and hide the other bodies. It looks very similar to previous, but it has some differences in geometry. But they have a similar problem, as you see, so we will try to fix it in the best way that we already found. Generate mesh on selected body. And that's good. We can try to use some additional property. Just a moment. Using box selected, we will select geometry like this. I will explain what I do. Just a moment. Nope. This one. Okay, and additionally I need this and this and this. We create sizing. We will say that we have number of division on these edges, 3. Also we will select just a moment, those edges. And we will say number of division 2. And now we create mesh for this part and hope it will be 2 elements here. It try, as we see, but it can't. And it can't in reason of this one. We doesn't have edges here, so it has some problem. Let's try to fix it. Here we have normal solution. 3. Okay. Face meshing. This one, this one, this one, this one, this one, this one. This all. Ouch. All those faces will be mapped. That's the first things we need to use. And second, we just a moment. Where it is? Ouch. Length of our 14 millimeters, we say 10 millimeters, so we want to have 3 layers, so sizing here will be 5 millimeters. Let's create generate mesh. Nope. We have good elements. Okay, we doesn't have good elements here. Face. Generate. Yeah, and we have mapped mesh, as you see. We also can check with mesh graphic, does we have 2 elements here, does we have 3 elements here on thickness. So if we will not have, we can go to body sizing and change, for example, 10 millimeters to 5 millimeters. Or we can go to the discovery, split this geometry to the more simple part, and use sweep method to create ideal mesh for this geometry. So we have mesh. We have mesh here without problem, and we have dump mesh here. Sizing, we will say 20 millimeters, and recreate this mesh. As you see, I select only one face, not an body, not a body. I select only mesh, and we get something like that. Ouch. Okay. We add the method to this body, and we say that it will be sweep, and recreate. Method to body, to a body, sizing to a face, and as you see, we have a very good variant of meshing. The only one thing that I want to change, it's 2 elements per thickness. Generate mesh. That's better. Also, we can do something like that for this object. We can say method sweep 2 elements. It's better to have 2 elements during thickness. So generate mesh. Ouch. Generate mesh. Bingo. This element have small size here and big size here, and the ratio of this element will be not perfect, but in reason that it's square element, square in form, it's very good topological form of this element. This difference are normal, so the mesh are good. Something like that we can do with these 2 rails. We can create mesh better here and sweeping during this direction, but we will not do this because we do something like that already for a big number of parts. For this part we will use method multi-zone. And we can use sizing for creating better mesh. Nope, multi-zone don't want. Ouch. For my thoughts, some objects that we use have more difficult geometry, and multi-zone are work normal, but in reason of Ansys he can't create a normal mesh here. So, or we must do a splitting by our hand, or we must create a tetrahedral or hex-dominant mesh here. Okay, I want to do some changes. First of all, as I see, I forgot to delete facets, small, here, yep. The first, and yes, we doesn't need these objects. Okay. So update apps, not mesh, geometry, update geometry. Sorry, my fault. He lost all elements, he lost all objects. Not finite element, but element of construction. Faces and so on. Okay, that's better. Let's create a multi-zone for this object. We'll create mesh for all objects, and then we create multi-zone for shaft. If you have some question about Ansys, if you have some question about CNC or so on, you can write it on a chat, or you can write below the video. If this question will be during the stream, I will try to answer to it. Even if this question are not corresponding to this task, but corresponding to Ansys computational mechanics and so on. For example, on previous stream, I answer on a question where to find a good tutorial and educational video on Ansys Fluent and Ansys in all. If you are watching this stream for now, and if you don't close this video, maybe it's time to subscribe and push the button, push the like button. Maybe it's time to write a comment for better understanding. but it's your decision. So let's hide all other body. And as you see, these shafts are very deformated because it creates automatic tetrahedral mesh and it's look like insane. Okay, let's use multi-zone method. I hope and I think that it will work here. So generate mesh on selected body, but we'll see. Yep, it works. And our shaft look much better. So let's open this geometry and let's try to create some additional splitting. We talk about this part, component, open component, and we do some splitting, as I said previously. So what do we need to do? Split body, this body with this surface, with this surface, with this face, okay, with this face, and with this face. Something like that must do a multi-zone, but as you see, it's not the simplest solution. So yep, it sometimes can be tricky. Additionally, we have, what the hell is this? Nope. All right. Okay. No, it's not right. We have to body here and we will delete it. Okay. And we select all our geometry, click here and share topology. What does it mean? Let's say first of all none and update geometry. Ouch. Yep. Select the first object and update geometry. My fault. Show all. Nope. I can understand why it's hide all geometry. Okay, let's open. Locate on tree. Yeah. Update geometry from source. Oh, okay. We have good geometry. Let's hide all others. Hide body. Hide body. Box select. Hide all other bodies, and we will create mesh here and show some very important things. First of all, as you see, they have different colors. When we select geometry, we have a preferences body color. We can change it from body color to part color or to another some things. And this is one part, as you see. So for now, we share topology. Share known. Sorry. I will create mesh here, and then I will do something other. So multi-zone. Okay. And create mesh. Generate mesh. Multi-zone don't work. Okay, suppress. Then select this one and say generate mesh without multi-zone. And mesh are created. Okay. And let's look something like that. And if you will take a look, you will see that we have one node here on all places. So if we will change, for example, a part color to body color for better viewing, and show mesh, we will see that mesh are connected. And for example, if we will try to select here nodes, Why do we not select node? Here we have only one node. If, for example, we will try to select node here, just a moment, we will see all elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nodes. And here we have only one node. And as you see, this node present in body 1 and body 11. So we change share topology here. From sharing to known, as it was by default. We return to our general assembly. We remember this place, and now we update our geometry. So we update and we see our parts, our 1FF body. We see all other bodies and we select them. Sorry, something like that. And say hide all other bodies and say go to corresponding bodies in tree. And here our first body, here are other bodies. And as you see, sorry, it have different color, but we have similar way of appearance of bodies when it was body color. But even if we now change part color, it will not be one color because it's different parts. It's not one part. When we create share topology here, when we create share topology, we create one part from different bodies, and for example, this face will be in two bodies, in this body and this body that I hide, for example. And if we will take a look here, we see that here we have two different points in one place. And when we create a mesh, we create mesh, and as you see, it's not in one place. Here, yeah, we have coincident. Here we have coincident because this geometry look the same, but for different geometry we doesn't have a coincident mesh. So it will work something like that. What is better? Better a coincident mesh. If we have mesh that coincident, we doesn't have a contact between those parts, and it works as real one object, but not as some objects that are glued to each other. I show how we can do it, so I will not spend time here. Show all bodies, and for this part, even for those parts, we can do transfer share topology, and we will create one object with coincident mesh. Okay, let's try to create multi-zone for this geometry. And we create, as you see, we create. For my thoughts, for my things, this object are not more complex than these bearings. But for Ansys algorithms, you can see the difference. One object can be meshed with multi-zone, and second can and can't. Okay. Additionally, this object hide all other bodies, and this can be meshed by multi-zone also. Generate mesh on selected bodies, and bingo! We have some problem here, and if you watch the first stream, you will see that I in one corner change situation, and during second corner don't change. And that's how it will look in place where we have changed, and that's when we don't have changed. And you see you have a lot of elements, about 10 elements, and you don't need them. It doesn't give any accuracy for this task here. So if you have some places with small geometrical object, you can do some changes to prevent mesh with small size, to prevent increasing of elements of mesh elements. Okay, let's use this motor. We can delete this motor and create a point mass instead of this motor, because this motor give only mass load to our construction. But we can change mass property of this object, and we can create mesh. It's not the right way, because we will have a lot of elements for this object, and if we will create point mass object, we will have only one element. But we can create, and we will create here a multi-zone method, and it must work. generate mesh, stitch, 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 bingo! We create something like that. And this is how our circle look like for a quad mesh with mid-side node. Red is mid-side node. Here we can see it's a square, and this node are mid-side, and this node blue are not mid-side. It's a node on corner. And here it looks like something like that. So if we select this object and go to corresponding bodies in tree and take a look into statistics, we will see that we have 130 elements and almost 1000 nodes for modeling this object behavior. And if we will change this object to point of mass, we will have only one element and only one node. For myself, better to change this geometry object to point of mass. Additionally, if we will open our mass properties, we will see that this object have 5 kilograms of weight, and if this motor have weight different from this one, from 5.3, for example, it have 3 kilograms or 6 kilograms or 8 kilograms or even 20 kilograms, we need to understand that if it's geometrical object, we must change our mass property to better coincidence, to better alignment to our statistic of our matter. But if we, for example, suppress this object, suppress this body, and use this face, and for example all these holes, I will not use these holes, but we can use it for creating point of mass, we can say that this motor weight 6 kilograms and that coordinate, for example, 174 millimeters. Nope. Then, for example, no. And center of mass, for example, here. And if we need to change our motor to another, we can change only 2 digits. This one, place here, and this one. If you doesn't want to create dump work with this digit, you can create system, coordinate system here. For example, we select this geometry. We create just a moment. We create a coordinate system here, for example. And when we create our point of mass, we can say that we will do it not in global coordinate system, but in this coordinate system, and change all digits to more simple variants. For example, in here, -50. That's more simple way. So it's more affordable way, it's more correct way, and you must do something like that. Okay, what we also must do, we also must work with those two objects, and we can create a multi-zone method for both of them. We have some problem with this geometry. Oh, no, sorry. We don't have mesh yet. With this geometry we doesn't have problem, but with this geometry we have. So open both of them and let's take a look. And we see that we have some problem. First of all, as I see, we have some virtual topology here. We doesn't need them. Here we can have topology virtual, but let's delete them. And let's try to create a mesh with the current option. And in most cases, yep, it can create. Why? We have a lot of faces. A lot of faces here, a lot of faces here, a lot of faces here, and so on. So it can't understand how we must to split this geometry. Let's return to virtual topology and let's generate virtual cells. Okay, here we have. Let's add some virtual topology by our hand. So we select this one. We select this one. I don't know, will it help? I hope it will help, but I don't know. But my understanding of algorithms say that it can help. Merge. Merge. merge and merge. Additionally, we need to merge those edges. So, pixel hunting. The most common task during finite element analysis. It will affect this geometry, but it's other situation. So with Control key we select all those edges. And let's try generate. Nope, it can't. Okay, let's change multi-zone to there are some options to hex dominant and generate mesh. Oh, press generate mesh. Even with topology optimization, we have some problem here. Okay, not topology optimization, virtual topology. So let's, unfortunately, virtual topology doesn't help to create a multi-zone mesh. Maybe only for now, maybe for all variants. Nope. Okay. Sizing. Sorry. Sizing 10. Generate. Look much better, but there are some problems. Ouch. Okay. We need to spend some time. It's not very difficult. It's look like other objects that we already do today, but we need to do some work. It's already almost 4 hours, so maybe I need to do rest some, but I don't want to break down reasons that I doesn't have mesh today. Yep, it couple times freeze and down, flat down, but I want to create mesh. I won't see the mesh. I won't see the mesh. Please, 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 please. And no one question. Strange. Maybe you have comments. For example, about English level, for example, about sound quality. Maybe you want to hear some, I don't know, tales. Our channel is FEArytales, so maybe someone wants to hear some tales in some direction, in engineering direction, but something like tales, FEArytales. Yep. We create a mesh here, and as you see, we have almost good mesh, but it's small size. So for my thoughts, if we will create here size like 10 or 15 millimeters, but then additionally create a local mesh control for these edges for 3 elements during thickness, and for these edges 2 elements, and for this edge and this edge 1 element per thickness, or for example here 2, here 1, here 3, and here 4 elements per edge, we will create a good mesh with not very big number of elements. So we have this object which haven't good mesh in the reason that we don't use additional preferences. We create additional preferences to not this object but to this object. So I will not create repeated. I already shows that we have possibility to create here good mesh, and we have good mesh for not very good mesh, but we have mesh for all elements, but not for X-beam. So X-beam, hide all other bodies, display closed vertices, something like that, virtual topology. Ouch. Ouch. Okay. Virtual topology, virtual topology. Automatically create virtual topology, but not create virtual topology for some edges. I don't understand why, but in some reason it works this way. Okay, merged cell. Here we doesn't need, here we need to create, oops. Merged cell. Okay. What the hell here? Okay, I see. Merge. Additionally, we need to create here. Yep, we have here possibility. Then we create here pixel hunting. And now we must create something like that here. Okay. Maybe it will not work in the right way if we will create here a sweep mesh for current moment, because we have difference in virtual topology here and here, but we doesn't have this difference. So show sweepable body. Yes, this object are not sweepable in reason of difference, but we already show how we can create here a good mesh. So we will not create good mesh here for now, and we will create mesh. Ouch, sorry. We will create some mesh here, and we will do some calculation. Create mesh. The full process of creating a very good mesh I will save in offline mode and increase speed for more dynamic, for adding the dynamic, something like that. Ouch, it doesn't want to create. I see. Nope. Ouch. Okay. Yeah, we create. Okay. It's not the worst mesh that I see, but it's very bad mesh. But we will fix they later. And okay, virtual topology. Merge cell. Ouch, I see. Okay. And okay. Oof. Okay. The only way is hunting on a pixel. Mesh. Generate mesh for selected bodies. As I see, delay in video is about couple minutes. Okay, we create here, and the last one that we need to check is it's that geometry delete. Yep. Bam, 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 bam. Bang, bang, bang. Merge cell. Merged cell. Merged cell. Okay, and mesh virtual topology Yep, something like that. Okay. Ouch. What the hell is this? Okay. Generate mesh. Yeah. Show all bodies, and I don't see body without mesh, but this icon says that we have some bodies without meshing. Okay, go to bodies, unmeshed bodies. Yep, it unmeshed. And why it unmeshed? Virtual topology, no. Hide all other bodies. Yeah, virtual topology. Yep. We delete all virtual topologies. So, generate mesh. Okay, show all bodies. The current statistic is about 500 of nodes and 1,500 of elements. 1,500 of 1,000 of elements and 500 of 1,000 of elements. Half of million. Okay. If someone remember what mesh do we have on previous version without simplification, we see that we have go to unmeshed bodies, hide all others. Okay, we haven't meshed on these bodies, and we have a mesh size about 1 and 2 million of nodes and 700 of elements. And I say that if we will create mesh here automatic, it will be about 1.5 or even 2 million of nodes and 1 million of elements. So this task will spend about 30-40 gigabytes of RAM, and this mesh will spend about, just a moment, we'll spend about 10 gigabytes of RAM, and we can create much better mesh, and we can create mesh less than 1 million. That will be very accurate, that will be very affordable, and it will be with good speed and with a good accuracy. So the only one thing that we need to do here is create automatic connection. It's put load, obtain solution, and we will stop this stream. If someone want to see process of creating full mesh, ideal mesh for all objects, not in high speed, not with increased speed up to 2, 3 or even 10 times, but in real life, please write a comment and I will show it. If during a week no one will write, I will show full process with increased speed. So what we should do? We must add loads, we must add connection group. It will be automatic connection, and create automatic connection. So we create all automatic connection. It can be not correct, in reason that some object will glue together, but they doesn't need to be glued. For example, this object can be glued to this object today, but for obtaining some result, it will be enough. We will hide this body. We will select this face and create a force, and we will create by components during Z axis in global coordinate system, and it will be 10 kilograms, so it will be 100 of newtons. It's from cutting material. Additionally, we need to add an standard Earth acceleration, say that in -y direction, and we can solve, but I think that we must change position of z-axis and move it here. So we can do this one using discovery. And it will be more simple result, because we can open this assembly, we can select Z assembly, we can move, and we can, for example, put it here. Here we can say move up to this object. We have some problem with these objects, but we can solve it in a very simple way. We will hide that object and select components with Control key. We select those objects, not X, sorry, Z-axis, and move oops, sorry. Okay, we will select this one, and on Y object we can select maybe it's more simple into step. Okay, up to this plane I start to freeze. Sorry. Ouch. I duplicate Z-axis. Yes, I duplicate Z-axis. Okay, and select component, those components, move up to those place. Please, assistant, leave our table. Or so move to this one. For example, something like that, and delete the axis we don't need. Okay, something like that. Sorry for my freeze and mistakes, but something like that. But we can do this one here. So what should we do? We need to hide our geometric object that we want to move. Hide body. Hide body. Hide body. We will found it here. Something like that. Invert visibility. This one will hide too. Okay. Now we select all object and create named selection. Selection named selection that that axis. I don't see anything. So now after we create selection, we choose model type, and choose part transform. Then we select named selection, and in named selection we choose that axis. And now we can translate in global system coordinate or in local, it's not matter. In X direction, for example, 100 millimeters. And we can do it with our with any precision that we need. We can measure distance and so on. It's not a problem. I will create it's about on my eyes, for example. Okay, we transform. It change position. We need to update our contact. Delete children. Update. We need to update mesh. Sometimes it lost some mesh for some object. And now we can fix our geometry. Fix here. And put this legs on a frictionless support. So and additional, this leg will be displacement that component 0. Okay. We can solve. It will spend some time, not very big. Additionally, we can take a look to how many memory and time it will use. FEAry Assistant. Or Fluffy Assistant. What is between the ears? Is it a brain? No, just fluff. So while it try to solve, I will show some things. Model was taken from CNC house and for supporting of creating content for FEArytales, you can be a Patreon, but it's your decision. It's your own decision. It will very help today when we have a war with Russia and my family live in another country without me, and we have some problems with works and so on, because our cities are attacked, but it's only a decision. So it's almost ready. %, 82%. And we doesn't get any result in reason that some objects are full. Rail 20. What is rail 20? Go to object, rail 20. I can understand what is it. Oh, I see. And why it? Well, something like that. So we create mesh during this stream. I show how to create a good mesh for any type of parts, but we don't solve this geometry because we have coarse mesh and we have some problems. some problems with gluing object. So we need to improve our mesh. We need to check our contact. For example, we need to select those two objects and say go to, where is go to? Here, go to contacts common for selected bodies. And we have contact, but it doesn't work. It doesn't work in reason of tolerance, maybe. Because as we see, we have about 3.5 millimeters of accuracy in gluing about nodes, and as you see, mesh here are very coarse. So today we will stop our video. Thanks all who watched till this time, and on the next week we will try to finish this task.